Welcome to Daily Papers, the podcast where we break down the latest and most interesting research papers into something a little more digestible.
Today, we're looking at a fascinating paper about teaching AI not just how to code, but how to work as part of a software engineering team. It's called Agyn, a multi-agent system for team-based autonomous software engineering.
Okay, that sounds complex. So we know AI, especially large language models or LLMs, can write code. We've all seen the demos. What's the problem this paper is trying to solve?
The problem is that most of these coding AIs work like lone wolves. You give them a task, like fixing a bug, and a single AI mind tries to understand the problem, explore the code, write the fix, and test it all by itself.
Right, a kind of AI genius working in isolation, but that's not really how software gets made in the real world, is it?
Exactly. Real-world software development is a team sport. You have project managers, senior developers who research the problem, junior developers who write the code, and reviewers who check everything before it goes live. There's communication, collaboration, and different people with specialized roles.
So this paper is saying instead of trying to build one super genius AI coder, what if we built an AI team?
That's the core idea. They created a system called Agyn that assembles a team of distinct AI agents, each with a specific job, to tackle software problems together.
I love that. It's like creating a little digital office. So who's on this AI dream team?
Well, first up, you have the manager agent. Its job is to coordinate everything. It reads the initial problem, decides who needs to work on what, and basically keeps the project on track. It doesn't write code itself, it just manages the process.
Okay, so it's the project lead. Who does it delegate to?
Its first call is usually to the researcher agent. The researcher's job is to dive deep into the existing code to understand the bug or the feature request. It explores the files, identifies the root cause of the problem, and then writes up a clear plan of action.
So it figures out what needs to be done. Then I assume someone has to actually do it.
Yep, that's the engineer agent. The manager hands the researcher's plan over to the engineer, and this is the agent that actually writes the code, makes the changes, and runs tests to see if the fix works. It's the hands-on coder of the team.
Okay, so we have a manager, a researcher, and an engineer. That sounds like a complete team.
Almost. There's one more crucial role, the reviewer agent. Once the engineer agent thinks it's done, it submits its work as something called a pull request on GitHub. This is standard practice in software development. The reviewer agent then comes in, inspects the new code, and decides if it's good enough.
And it gives feedback like a human reviewer would?
It does. It can leave comments saying, this part isn't quite right, or you missed something here. The engineer then has to take that feedback, make more changes, and submit again. This loop continues until the reviewer is satisfied and officially approves the code. The whole process is completely automated.
That's incredible. It's a full automated feedback loop. So the big question is, does it actually work? How do you even test an AI software team?
That's where a famous benchmark called SWE bench comes in. Think of it like a really hard final exam for AI coding. It's a set of hundreds of real-world bugs taken from popular open-source projects on GitHub. The AI has to fix them, and the fix has to pass all the original tests.
And how did the Agyn team do on this exam?
They did fantastically well. The system successfully resolved 72.4% of the tasks it was given. For comparison, a strong baseline system using a similar AI model on its own only solved about 65%. So building a team made a significant difference.
Wow, a 7-point jump is a big deal in these kinds of benchmarks. What's really interesting is that they used different AI models for different roles.
Yes, and that's a really clever touch. The manager and researcher agents, which need to do a lot of high-level thinking and planning, used a more powerful general-purpose AI model, but the engineer agent, which is just focused on writing and fixing code, used a smaller, more specialized model that's optimized for coding. It's more efficient and cost-effective, just like in a real company where you'd assign tasks based on people's skills.
So the big takeaway here, is it just that teamwork makes the dream work even for AI?
That's pretty much it. The argument that for AI to get better at complex tasks like software engineering, we need to focus not just on making the AI models smarter, but also on how we organize them, the structure of the team, the workflow, the communication channels. What they call the organizational design is just as important as the raw intelligence of any single agent.
It makes a lot of sense. A team of specialists will almost always outperform a single generalist. Did they run into any funny or interesting challenges?
They did. One challenge was that sometimes the AI team would try to be too helpful. In the real world, when a developer fixes a bug, they might also clean up some nearby code or add a new test. The Agyn team did this too, but the benchmark only wanted the absolute minimum change to fix the bug. So the AI was being a good real-world developer, but a bad test taker.
That's hilarious. It was over-engineering the solution. It sounds like the most impressive part is that this system mirrors the human process so closely.
Exactly, and the authors point out this system wasn't even designed specifically to beat this benchmark. It was built for use in a real production environment, which makes its high score even more meaningful. It suggests this team-based approach isn't just a trick to get a high score, but a genuinely robust way to build autonomous software systems.
So the future of AI coding might not be a single all-powerful AI, but entire companies staffed by specialized AI agents, all collaborating on projects. A fascinating glimpse into the future.
Absolutely. It shifts the focus from just building a better brain to building a better organization.